The objective of this lesson is to solve systems of equations with 3 variables and 3 equations. We've been solving systems with 2 variables and 2 equations, and to extend it to a 3rd variable and a 3rd equation, we're going to need to make sure that we're strategic and follow certain steps to get there. So our first step for doing this is to set up 2 pairs of equations to eliminate the same variable. So I might pick the top 2 and then the bottom 2, put those in pairs to eliminate one of the variables, either the x, the y, or the z. But it has to be the same variable that we try to get rid of in both equations. The second step is to use elimination to get a system of 2 equations with 2 variables. The third step is to solve the system. And then the fourth step is to use substitution to make sure you get all 3 variables. All right, so looking at this example here, what I like to do when I do these examples is I like to make sure that I set it up by numbering the equations. So I'll just put a number next to each one of them just to keep track of which equation I'm dealing with. Now, looking at the variables and deciding which variable to get rid of, my choice here is going to be the x's. Now, here's the thinking behind it. If you look at the z's, we could get rid of the z's in the first 2 equations pretty easily, maybe by multiplying the second equation by -1 and adding. But to get to this -3 for pairing it up with one of the other ones, because you have to use all 3 equations, that would be difficult to do. Similarly, with the y's, to get the y terms to be eliminated would take some work. You can do it. You can actually do it with any one of the variables. It's just that some are easier, because if you look at these x's, already 1 and 3, when we put those 2 together, if we pick 1 and 3 as our 2 equations, notice already the x's are opposites, so they're all set. Also, the second one, I could easily get one of the other 2 to pair up with the second equation and eliminate it there. So on this one, I'm going to eliminate x's. And I have to make sure in both pairs I do that. So let's go ahead and do the first and the third. I'm going to just line them up. Opposite of x plus 2y plus 2z equals 6. And then I'll write out the third one, x plus 5y minus 3z equals -2. And if you look at those, I can add straight down already. I don't need to change anything. You just add straight down, and the x's are eliminated. So 2y plus 5y is 7y. 2z plus -3z is -1z. And then 6 plus -2 is equal to 4. So I've got my first equation by adding the first and the third. Now let's go ahead and I'm going to do the first and the second. I could choose the second and the third, but I've got to include the second equation as one of these. So I'm going to do equation 1 and number 2. I'm going to just list out 1 as is, -x, opposite of x, plus 2y, plus 2z equals 6. Then I'm going to list the second equation as is, 2x minus 3y plus 2z equals 7. Now, I want to get rid of the x's. Notice that I might be tempted to get rid of the z's in this case because it would be easier, just multiply by -1. But you always want to get rid of the same variable that you got rid of in the first pair. Otherwise, the rest of the steps don't work out. So I'm going to go ahead and multiply the first equation by 2. So write it like this, times 2. And so I've got my first equation is -2x plus 2 plus 4y. And then 2 times the 2z is plus 4z equals 2 times 6 gives me 12. And I'm going to just list the second one as is. I don't need to change anything on it. So 2x minus 3y plus 2z equals 7. Now I'm going to add straight down on those because now that will get rid of my x terms. So no more x's when I add. 4y plus negative 3y is positive 1y. 4z plus 2z is going to be 6z. And then 12 plus 7 gives me 19. Okay, so y plus 2z, or 6z is equal to 19. Now I'm going to take these two equations, this one, and I'm going to make a system of equations with these two. 7y minus z equals 4. And then take this one and rewrite it over here. Y plus 6z is equal to 19. Now what you can do is to solve the system, you can use any of the techniques that we've done before. You could use substitution, or you could use elimination. You could use graphing also. I'm going to go just stay consistent and use elimination again. I'm going to look at this and say, if I multiply the top equation by 6, then the z's will be canceled. And so I'm going to go ahead and do that. So times 6. Substitution would work just fine for this. So 6 times 7 is 42y. 6 times opposite of z is negative 6z. And 6 times 4 is equal to 24. Here I'm going to just rewrite this one as is. And then I'm going to add straight down just to get rid of the, in this case, the z's. So 42y plus 1y is 43y. No more z's. 24 plus 19, that gives me 43. Divide both sides by 43, and you get y equal to 1. So we solved for our first variable. We've got one of them. Now we've got to go back and substitute back in to get the other two variables. Let's use this y equals 1 into one of these two equations to work our way back up to the top. So put 1 in for y here. So I'm going to put it in the second one. So I'm going to have 1 plus 6z equals 19. So let's substitute in that 1. Subtract 1 from both sides. 6z equals 18. Divide by 6 and you get z equal to 3. So now we have a z and a y. We need to go back and get x. Let's go back to one of the original equations for that. So I'm going to just go ahead and pick the third equation for this. So third equation, I have x plus 5y minus 3z equals negative 2. I'm going to solve for x, so I'm going to put in, for my y, I'll put in 1. For my z, I'm going to put in 3 from this, equal to negative 2. So x plus 5 minus 9, so I've got plus 5 minus 9 will be minus 4, equals negative 2. Add 4 to both sides, and you get x equal to 2. Now for this, just as a note, you always want to list your answers in the format of, I'll just put it underneath here, it's going to be x, comma, y, comma, z. Just keep it alphabetical. It'll be a triple, three numbers for the answer. So when I list this, I'm going to get 2 for x, 1 for y, and 3 for z for that. There's my answer for this system of equations. So following these steps, notice keeps us organized to get each one of the variables. It's very important that you show it in a way that is that others can follow your steps. All right, let's go ahead and do example 2 here. I'm going to number my equations. This is 1, 2, and 3. Now to eliminate these, again, you could get rid of the x's, get these to be opposites. Probably be a little difficult to do, but you could do it. You can easily get rid of the y's. The z's, also not a bad choice, because these, you can make these opposites, and you can make this, multiply this by 2 to get negative 2 to get to be the opposite of one of them. So really, you've got two good choices, either y's or z's. You can do either one, but you have to show your work carefully so that others can follow the steps that you use. So I'm going to go ahead and eliminate my y's. So the first thing I'm gonna do is, the first pair I'm gonna do is just pair up 1 and 2. They're already opposites. So I've got 2x plus y plus 2z equals 6. And then I just paired up with this one, 3x minus y plus z equals 1. Clearly labeled which ones I chose. Show your elimination by adding straight down. So 2x plus 3x is 5x. No more y's when I add those straight down. 2z plus 1z is equal to 3z. And 6 plus 1 is equal to 7. There's an equation, y eliminated. Let's go ahead and do another pair. So I've got to pair up to get rid of y's, and I've got to include this third one. I'm going to use the second equation, because if I multiply it by 2, then the y's will be eliminated. So I'm going to use 2 and 3. So let's list out 2. And let's list out 3. Okay, to get rid of the y's, I'm going to multiply the top equation by 2. So let's just relist it here. I'm going to have 6x minus 2y plus 2z equal to 2. Now let's do the second equation, just listed as is, 5x plus 2y plus 2z is equal to 3. Now again, you'd be tempted, you got to resist the temptation here. You could have gotten rid of the z's here pretty easily by multiplying the top one by -2. But you got to remember that if you got rid of the y's here and you get rid of the z's here, the next step of solving a system isn't going to work because the variables won't match. So you have to make sure in both pairs you get rid of the same variable. So add straight down, you got 11x, no more y's, eliminated, plus 4z is equal to 5. Now we're going to take these two equations and rewrite them. 5x plus 3z equals 7. 11x plus 4z equals 5. And we're going to solve this system of equations. Now you can tell from this that this one's not going to be as easy to get rid of the variables as quickly. How do we get rid of the x's or the z's? Substitution is not a great option here either, because getting one of the variables by itself will give me fractions. So I'm going to go ahead on this one. I'm going to get rid of, in this case, the x's, and I'm going to have to multiply both equations. So if I want to get rid of the x's, I'm going to make this 55x and negative 55x. So I'm going to multiply this one by 11. So I get 55x, and then times 11 gives me 33z. 11 times 7 gives me 77. And now the second equation I'm going to multiply by -5 to get the x's to be opposites. So multiply everything by -5, I get negative 55x, negative 20z, and then -5 times positive 5 is negative 25. I'm going to add straight down. Now, no more x's when I add straight down. 33z plus negative 20z is going to be a positive 13z. And then 77 plus negative 25, that's going to give me a 52. All right, now I can solve that. I go ahead and divide both sides by 13. And I get z equal to 4 when I solve that. Next step is to go ahead and substitute back into one of these two equations. So I'm going to take this, and I'll take this equation, this value, and I'll go with 11x plus 4 times 4 equals 5. So 11x plus 16 equals 5. 11x here. Now I go ahead and subtract 16. 11x equals negative 11. Divide by 11, you get negative 1. So I've got my x, I've got my z. How we get back to get the y that's still missing is go back to one of the original equations. I'm going to go ahead and just use the first one here. So equation 1 is 2x plus y plus 2z equals 6. I'm going to put in x here. I'm going to put in z, which is 4. I'm going to solve this. So I get negative 2 plus y plus 8 equals 6. Negative 2 plus 8 gives me a positive 6. Subtract 6 from both sides, you get y equal to 0. So now I'm going to list my ordered triple, negative 1 for x. Remember, it goes x, y, and z in alphabetical order. X, y, and z. There's my solution to this system of 3 equations with 3 variables. If you put this point into each of these equations, it will make a true statement. It's the only ordered triple that will do that. So just a reminder, we've extended our systems of equations to 3 variables with 3 equations. You now have to follow a very organized and strategic method for finding each of the variables. Use elimination first, then you can go back to substitution and get all 3 variables solved for your ordered triple.